Hello, so in today's video, we're going to look at a brief summary of quadratic sequences. So in yesterday's video, we looked at linear sequences, so sequences where the difference between each term is a constant value. Today, we're going to look at quadratic sequences. So actually sequences where the second difference between each term is a constant value. So yeah, sequences with an nth term in the form an squared plus bn plus c, where a, b, c are real numbers. These are called quadratic sequences. So let's look at some examples. So this example here, 27, 23, 17, 11, 1, that would be an example. So that is an example. And why is that? So basically, if we look at our differences between our numbers, so to go from 27 to 23, that's -4. To go from 23 to 17, that's -6. And then -8 from the third to the fourth term, and then -10 from the fourth to the fifth term. Obviously, the sequence carries on, so on and so on. So if we look at the second difference, so that's our first difference. So first difference. Our second differences are all going to be constant. So our second differences, in this case, -2. So to go from -4 to -6, you add -2. Then you add -2 from -6 to -8. And then you add 2 to go from -8 to -10. So the second difference is a constant. So if they are constant, let's just make a note of this over here in green. If second differences, let's try and write this again. So second differences of a sequence are constant and non-zero as well. I'll just make a point and emphasize that they must be non-zero, are constant and non-zero, then sequence is quadratic. Okay, so this sequence here is certainly a quadratic sequence because our second difference is constant and it's non-zero, so it must be a quadratic. However, this one here is not quadratic. So let's think about this. So we've got a first difference here of 2, a first difference here of 4, a first difference here of 8, and a first difference here of 16. Now the second differences go 2, 4, 8. These are not constant, so these are not constant second differences, so not constant second differences. So therefore, it's not a quadratic sequence. A quadratic sequence, quadratic sequences must have a constant second difference, and it must be non-zero as well. So otherwise, if it were to be a 0 second difference, it'd actually be a linear term. If your first differences were all constant and non-zero, that would be. So now let's look at how we'd calculate the nth term of this specific sequence that I gave on the previous page. So 27, 23, 17, 11, 1. How could we calculate the nth term of that? Well, we know that the nth term must be in the form an squared plus bn plus c. So we know it must be in that form there. So what we can do is just substitute in n equals 1. So when we substitute in n equals 1, we get a plus b plus c, because plugging in 1 just gives us a plus b plus c, and we know that's going to be 27. Okay, now let's plug in n equals 2. If we do that, we're going to get 2 squared times by a, which is 4, so 4a plus 2b, and then plus c at the end, and this is going to be 23. And now let's plug in n equals 3. So we're going to get, in this case, so n squared, 3 squared, which is 9, so 9a plus 3b plus c at the end. That's going to give us 17. So let's call this equation number 1. Let's call this equation number 2. Let's call this equation number 3. Okay, so we've got 3 equations there. Now let's look at the differences between equation 1 and equation 2. So if we do 1 take away 2, so that's going to give us the equation. Actually, sorry, let me do it the other way around. Actually, sorry, let me do equation 2 take away equation 1. Okay, so if we do this, we're going to get 4a take away a. That's going to give us 3a, and then we're going to get 2b take away b. That's going to just give us b. C take away c. Well, that's just going to give us 0, because c take away c is 0. And 23 take away 27. That's going to give us -4. So this must be equal to -4. Okay, so we know that. Now let's look at our next difference. If we do the third equation, take away the second equation, in this case we get 9a take away 4a, that's going to give us a 5a. 3b take away 2b, that's going to give us a b. C take away c, again that's going to give us just a 0. And then that's going to be equal to 17 take away 23, so -6. So basically that term there and that number there is basically what we've worked out there. Now, if we call this equation, I'll call it equation capital A, call this one here equation capital B. If we do equation capital B, so therefore equation capital B, take away equation capital A, so that's going to give us, so 5a take away 3a, that's going to be 2a. And then b take away b, 0. And that's going to be equal to -6 minus 4. So 2a equals -2. So therefore we know that a must be -2 divided by 2 must be 1. So we know that a equals 1. Okay, so now we can just plug in a equals 1 into one of these formulas here. So the a or b formula. Let's pick a. So therefore a equals 1, we get 3 times -1 plus b is equal to -4. So therefore b is equal to -4 plus 3. So that's going to give us a -1. So we know that b equals -1. And then, okay, so we're nearly there. We've got a, we've got b. How about c? We can use equation number 1, this equation there. So we know that therefore -1a plus b, which is -1, plus c is going to be 27. So therefore, add 1 to both sides, add another 1 to both sides, you're going to get c equals 29. So therefore, the nth term, so that's going to be minus n squared minus n plus 29, because the a value is -1, the b value is -1 as well, and the c value we just found out to be 21. So that would be how we would calculate the nth term of that sequence, just by getting some simultaneous equations and then solving those simultaneous equations. So that's one way in which you can calculate nth terms of quadratic sequences. And obviously to identify them, you just got to make sure that your second differences of the sequence are constant and non-zero. And if that's the case, you have a quadratic sequence. So yeah, that's just a summary of how quadratic sequences work.